This is lesson 3-5A from the Algebra Readiness textbook. For today's lesson, you will need your Chapter 3 notes packet and a sharpened pencil. Begin by working these study guide problems. When you've completed these problems, continue the video to compare your answers with mine. The first question is that you want to buy 8 CDs for $15.29 each. Estimate the total cost and show what numbers you use to arrive at your answers. The first thing you might have done was taken 10 times 15 and gotten $150. Others of you might have taken 8 times 15. 8 times 10 is 8. 8 times 5 is 80, and then 8 times 5 is 40, so you would have gotten $120. Now there are other answers, but these are just two. The next one, estimate 99 3/10 divided by 9 9/10 using compatible numbers. Perhaps you would have used 100 divided by 10 and gotten 10. Perhaps you used 99 divided by 9 and gotten 11. These are just two examples. You might have done something different. The next one, you earned $86.20 and you would like to buy some new t-shirts. Estimate the number of t-shirts you can buy if one costs $12.30. I'm going to put a star by this one because that one is identical to a problem that will be coming up on your test. So you've earned $86.20 and each t-shirt is $12.30. So really, it's $86.20 divided by $12.30. Some of you might have rounded this to 90 divided by 10 and said about 9 t-shirts. Others of you might have done 80 divided by 10 and gotten 8 t-shirts, or any variation in between there. Number 7A, estimate the product of 2319 times 1387 by rounding each factor to the nearest whole number. That's the ones place. So that would mean 23 times 14. 4 times 3 is 12. 4 times 2 is 8, plus 1 is 9. I put my 0 down. 230, now I have to add them. And I got 322 using that method of estimation. Do you see how I still had to do a side problem with that version or method of estimation? Look at letter B. Find the same product using a different strategy. This time, instead of rounding, we are using compatible numbers. Compatible numbers are numbers that are easy to do in our head. So maybe we would take 25 times 10 and get 250. Now, notice my compatible number is further away from the exact answer. However, it was much easier to estimate in my head. Other people might have taken this as, let's see, what might you have done? 20 times 15. And you would have gotten 300 using compatible numbers. So which method do you prefer? The method in part A or the method in part B? Most people choose part B because it's easier to do the math in your head. So that was a review of estimation from yesterday, or our last lesson. So today we're going to use that estimation that we learned about in order to check our answers and our accuracy on our answers when we're solving equations. Today, we're going to multiply positive and negative decimals. Before we can multiply positive and negative decimals, we need to review the rules for multiplying and dividing integers. You will want to write these rules down in your notes. When you're multiplying, if you have two numbers with the same sign, the answer will be positive. For example, -4 times -7 is a positive 28. 5 times 3 is also a positive answer. And so if the signs are the same, you will have a positive answer. On the other hand, if the signs are different, you will have a negative answer. Let's see, 4 times negative 7 is a negative 28. Or negative 5 times 3 is a negative 15. These are all review of what we learned in the first chapter of this textbook. So these are the different signs, negative answer. Same signs, positive answer. Take a minute, write that down. Now we also need to review rules for multiplying decimals. Seems like my formatting is a little wonky. So remember that when you're multiplying decimals, you multiply like the decimals aren't even there. Then you count up the number of places in the problem after the decimal points and count that many places in from the right of your answer. So let's do this example together, and this one should go in your notes packet. I like to write these in stacked formation like this, 8 3/10 and 1800ths. Notice I did not line up my decimal point. I'm going to multiply like the decimals don't even exist. 8 times 3 is 24, carry the 2. 8 times 8 is 64, plus 2 is 66. I put my 0 down. 1 times 3 is 3. 1 times 8 is 8. Then I add these together. 4 plus 0 is 4. 6 plus 3 is 9. 8 plus 6 is 14. And now I have my number, 1494. I can use estimation to figure out where that decimal point should go by 10 times 2/10, and know that that means 10 times 2/10 is close to 2. And where can I place my decimal point such that I get a number close to 2? Well, if I place it here, that's 149. If I place it here, that's 14 9400ths. That's not close to 2. If I place it here, I get 1 and 494 thousandths. There, that would be close to 2, so I could just place it right here using estimation. Another way, which is the most common way that you've learned, is to count how many digits are after the decimal point in the problem. In the first number, just the 3, so 1 digit. In the second number, 1/8, so 2 digits. Total of 3 places. 1, 2, 3 places. And so both methods put my decimal point right after the 1, either by estimating or by following the rule of combining the number of digits after the decimal in the problem. Hopefully that's review. Oh, hold on. Do you see I missed something big? This is a positive number. This is a negative number. A positive number times a negative number gives me a negative answer. And so I should have written a negative 1 and 494 thousandths as my answer. All right, pause the video here and give this problem a try. Multiply these two and then make sure you don't do what I do. Make sure you go back and put the sign of the answer. All right, let's work this problem out together. 60 6/10 times negative 35. Notice I did not line up that decimal point. Yours should look just like mine. 5 times 6 is 30. 5 times 0 is 0, plus 3 is 3. 5 times 6 is 30. I'm done with that 5. I put a 0 down, and then I start in with the 3. 3 times 6 is 18. Carry the 1. 3 times 0 is 0, plus 1 is 1. 3 times 6 is 18. Now I'm ready to add these together. 8 plus 3 is 11. 1 plus 1 is 2. 8 plus 3 is 11. Carry the 1. 1 plus 1 is 2. Now I go back to my problem and I say, how many places or are there after the decimal point? In the first number, there's 1. In this number, there's 0. So I move the decimal a total of 1 place in. And then I need to add a comma. So my answer is a negative times a negative is a positive 2,121. The next one that you gave a try on your own, you should have written. Again, notice I did not line up my decimal points. It's very important that you memorize these rules. 4 times 2 is 8. 9 times 4 is 36. Carry the 3. 4 times 0 is 0, plus 3 is 3. I'm done with the 4, so I put my 0 in. Now I begin the same process with the 9. 9 times 2 is 18. Carry the 1. 9 times 9 is 81, plus 1 is 82. Then I add. Now I need to place my decimal point. There are 3 digits in the first number, and there is 1 digit in the second number, for a total of 4 digits. 1, 2, 3, 4. My answer is a negative times a positive is a negative 0. So 8,648 ten-thousandths. Negative 8,648 ten-thousandths. All right. Sound is used to measure ocean depth. Sound travels 1 5/10 kilometers per second through water. It takes 3 7/10 seconds for a sound to reach the bottom of the ocean. How deep is the water? Okay, let's try that one more time. Sound is used to measure ocean depth. Sound travels 1.5 kilometers every second through the water. If it takes 3 7/10 seconds for sound to reach the bottom of the ocean, how deep is the water in that location? I need to multiply these two numbers together. 1.5 kilometers for every 1 second, and there were 3 7/10 seconds. 7 times 5 is 35. 5 times 3 is 15. 3 times 1 plus 3 is 4. Then we're going to add these together. Now I need to place my decimal. There is 1 digit here and 1 digit in the second number that follows the decimal point for a total of 2 digits. So my answer is, how deep? 5 55 kilometers deep. Remember, a kilometer is just a little over a half a mile. And so that should help you know how deep that is. It's not 5 miles deep. It's about half of that in miles. All right, hopefully you're able to multiply on negative, positive, and negative decimals. See, I'm thrown off because I wrote add and subtract, and I should write multiply. So let's see if you can multiply these 2 digits or 2 numbers together and put the right sign of the answer. Pause the video and come on back to compare. All right, notice I just wrote these down without lining up the decimal point. 5 times 4 is 20. 5 times 0 is 0 plus 2 is 2. 5 times 5 is 25. Now I go to the 6. 6 times 4 is 24. 6 times 0 is 0 plus 2 is 2. 6 times 5 is 30. Now this last 0, sometimes I catch kids wanting to multiply that out. Multiplying or adding a row of zeros in the next row doesn't change my answer, so it's really not worth your time to do it. It doesn't change your answer. 4 plus 2 is 6, 5 plus 2 is 7, 2 plus 0 is 2, and then I get a 3. Now let's count up digits. 1, 2, 3 digits. oops, this one, and this one. So I'm gonna move that decimal point in 3 places, and my answer is a positive times a negative is a negative 32 and 76 hundredths. Give the 3-5A worksheet a go and make sure that you ask if you have any questions on this. Show all